Hello guys, welcome back to my channel. Today we are starting with a new chapter and which is refraction of light. So I hope you are doing well. All your preparations are going good. All the best for your boards. Happy learning. So without wasting any time, let's just get started. Okay. So today's chapter is refraction of light. It's a very easy chapter again and all the concepts from this chapter are very easier if you have studied it well. So, starting with the path of light. So, the basic concept about light that we know that it travels into the straight line, which are called as rays. Light always travel in the straight path, which is called as rays. This is not a straight line, but may you consider it as straight line. This is a path of line. This is a path of light which travel into the straight line, and it is called as ray. Ray also have arrow to indicate the direction of travel of light. So if I have drawn this way, so this means light is traveling into this direction. An example of ray is the beam of light from the laser. Okay, so laser is an example where we can see the path of light or the direction in which it is traveling. Okay, so we must consider or we must know that light always travel into the straight line. Okay, so today you are going to learn about refraction of light, laws of refraction, how to draw the ray diagrams since it is the part of the another chapter as well. So let's see how does it goes. Then refractive index and dispersion of light. Now there are some other concept related to this chapter as well, which I haven't tried it here, but we will complete it. Like there is the total internal reflection, and then we have partial reflection, mirage, formation of rainbow, and all this chapter, all this concept, we are going to complete it. Okay. So moving on to the next part, starting with the refraction of light. Now, what does it mean, the refraction of light? Whenever the light changes its direction when going from one transparent medium to the another transparent medium, this is called as the refraction of light. Now, some important part or which I want you to know, that there is a difference between refraction and reflection. Please don't be confused in both of this, because reflection has L in it, LECTION, and this is refraction, which is FRACTION. Okay, so what does it mean? Whenever a light is traveling from one transparent medium to another transparent medium. Okay, so on a very second, when it will cross this line, when it will hit the boundary or when it will hit the surface of the another medium, then what will happen, it will change its direction to the another direction. It won't be traveling into the same path. Okay, so this light has traveled this path over here until it has uh, touch on the moment, since the moment that it has touched the surface of this surface of the another medium, it will change its direction, and this phenomenon is known as refraction of light. So where does this bending occurs? This bending occur only at the boundary between the two media. Okay, and one more condition is there, that that media or that surface should be the, not the surface, but the media should be the transparent medium. Okay, that medium should be the transparent, and the refraction will occur only at the boundary between the two media. And refraction is observed because light travel at different speed. Now why does this has happened? Because light has a different speeds in different medium. That's why we see the phenomenon which is called as refraction. So this is a very clear concept. This is very easy concept to remember, that light changes its direction when it is traveling between the different mediums, different transparent medium, and it changes its direction because light has different speed in the different medium. Now ray travels in the straight line until it hits something. Okay, because we know that light travels in the straight line, but until it hits the something. So whenever it is hitting something, it will change its direction. Okay, so this phenomenon is called as refraction. Moving on to the next concept. Okay, now ray model of light. Okay, ray model of light is what? What is it? Ray model of light. When the light ray encounters an object, they can be reflected, absorbed, or refracted. Now we have the three concept for the light ray. So sometimes when it heat the surface, when it heat or touches the surface, it will get reflected back, not refracted but reflected. The reflection occurs when light ray bounces off the surface. So now I have said that the refraction will happen only when the medium are transparent. But what if that medium is not transparent? Then the phenomenon that reflection will be happen when it will not travels into the different medium, but what it will do, that it will touch the surface and bounce towards a different direction. That this phenomenon is called as the reflection of light. Now absorption, what does the absorption means? Absorption, when the material takes in the light. Okay, it hasn't bounces toward the different direction, but when something is absorbing heat, sorry, when something is absorbing light, this phenomenon is absorption, and generally it converts to the heat, because of the light rays converting to the heat, not to the greater proportion, but it will gain some heat, it will convert into the heat. Now refraction, we have already seen this concept. Refraction is when light passes through the transparent material like glasses or water, so it will change its direction. So these are the three ray model for the light. Now, important terms used in the refraction. What are the important terms that we see in the refraction? These are the incident ray, refracted ray, normal, angle of incidence, and angle of refraction. Now, what are these terms? Now, incident ray, the ray falling on the surface. This ray, this blue ray. So this blue ray is incident ray. Okay, the ray which is falling onto the surface, this ray will be called as incident ray. Similarly, the refracted ray, the ray which has refracted, I mean, this light has to travel into this path. Okay, this is the original path. But since it has traveled into it has transferred, or it has undergone into the different medium, it will change its direction. And this is this ray. Now the original position has changed, and now the ray will move in this direction, which is called as a refracted ray. So we have two new terms here, that is incident ray and refracted ray. The incident, the ray which was falling onto the surface, and the refracted ray, the ray bending in the second medium. The bent ray in the second medium which will be called as refracted ray. Now normal, the perpendicular line at the point of incidence. So this black line, okay, this perpendicular line to this surface, this line has made the perpendicular to the surface. Now this will be called as normal, that will form at the angle of incidence. This will form by the incident ray and the refracted ray. Okay, so this line will be called as normal, which will be the perpendicular to the surface. Okay, now angle of refraction and angle of incidence, the angle between incident ray and normal. Wait a minute, let me just clear this. Okay, this angle which we see here between the incident ray and the normal, this angle will be called as angle of incidence, which is represented here by the eye. Okay, similarly, the angle between the this refracted ray and the normal, it will be called as refracted angle of refraction. Okay, and that is represented here by the R. I hope these all new terms are clear to you. Moving on to the next part, laws of refraction, which is a Snell's law. Now, Snell has given us some laws for the refraction. Let's just revise it. First law, what does the first law for Snell's say? Okay, the first law for the Snell's, what is it? The incident ray, refracted ray, and the normal at the point of incidence lie in the same plane. This is a very easy law to understand and to remember, which means that this incident ray, this normal, and this refracted ray will lie at the same plane, which is at the point of incidence. Okay, so this is the Snell's first law. Now what does the second law says? For a given pair of the media, sine I upon sine R will be the constant. Sine I upon sine R will be the constant. Now let's just draw a triangle over here, and you can see that for the sine, opposite side upon hypotenuse, opposite side upon hypotenuse. Now if we consider this will be the hypotenuse here, and for this triangle this will be the hypotenuse here. So here what does it mean? That opposite side upon hypotenuse, this will be the opposite side. Okay, this will be the opposite side if we consider this side as the hypotenuse side. This is the hypotenuse side. Okay, and for this triangle this is the hypotenuse side. So opposite sign for sine I and sine R, this is constant. Okay, so this normal will be the constant for both of this triangle. That's why we have chosen here sine. Okay, so sine I upon sine R. Sine I means sine angle sine of incident angle, and sine R means the incident for the refracted angle. Okay, so that will be the constant, that is normal. Okay, so this both of these laws are very easy. Please don't lose any of your marks over here for this both of the laws. Okay, now here we have the new concept, which is refractive index, which is represented by the constant, which is nu. Okay, now the refractive index of medium will be defined as nu, which will be given as a ratio C upon V, where C will be the speed of light in the vacuum and V will be the speed of light in the medium. Okay, now properties of the refractive index, it won't have any unit, SI unit. The refractive index won't have any SI unit. It will be always greater than 1 except vacuum. And what does it mean? That in the vacuum the value for the refractive index will be the 1, and for other substances it will be for other medium it will be greater than 1. Higher mu, more bending of light. If some refractive index have the greater or the higher value of mu, it means that there's a more bending of light. Now on what substance, on what basis it changes, and on what factor does it depends? So it depends on nature of medium, it depends on wavelength of light, because we know that different color or the different light changes into the different colors, and it will also change its wavelength. So the refractive index will also depend upon that. So it depends upon nature of medium, wavelength of length, and also the temperature. Okay, so this is about refractive index. Keep in mind that it won't have any unit, definite unit. Now, absolute and refractive index. Sorry, absolute and relative refractive index. Absolute refractive index of the medium with the respect to the refractive index of the medium with respect to the vacuum. Refractive index of the medium with respect to the vacuum, we have already seen here for the light ray which is traveling into the speed of light in the vacuum, it will be clearly represented by C, and for the speed of light in the medium it will be represented by V. So when we are talking about refractive index of the medium with respect to the vacuum, refractive index of medium with respect to the vacuum, we will be defining as mu. And please keep in mind that this terms with respect to it clearly confuses the student to how to write about it. So nu, okay, and with respect to the vacuum, if we have with respect to whatever we are taking with respect to, okay, so whatever medium we are taking with respect to, it will be written on the upper position on the vacuum. So we can write C here, and with the respect to the medium we will write V over to the lower position. Okay, so this is how the absolute refractive index will be symbolized. Now for the relative refractive index of one medium with respect to the another, so that will be the relative refractive index. So absolute and relative are somewhat similar but distinct on the same time. Absolute refractive index is only for the refractive index of medium with respect to the vacuum, but relative is for refractive index of any medium with respect to the another medium. Okay, so again, if I'm talking about the refractive index of second medium with respect to the one, so the respected medium will be written on the upper position, and the another one will be written at the lower position. Okay, and for the medium we will write v. So that's why v2 upon v1. Okay, since the speed of light in the medium is represented by v, we have to write v2 upon v1. Now, direction of bending of light when it is traveling from the rarer medium to the denser medium. For example, if it is traveling from air medium, which is rarer medium, to the glass medium, which is denser medium, the speed of light decreases. Okay, so the speed of light will be decreasing. Okay, the speed of light will be decreasing. So light bends towards the normal. Okay, so here when it is traveling between the rarer medium to the another medium, which is denser medium, so what will happen? The speed of light will decrease and light will bend toward the normal. Okay, light will bend toward the normal and not move away from the normal. So what will happen here? Let me just draw it again. Let's suppose this is the incident ray and this will be the normal ray. Okay, this will be the refracted ray. So light bends toward the normal. Angle of refraction will be smaller than angle of refraction here. Okay, from the angle of incidence. So light bends toward the normal. On contrast, when light is moving from the denser medium to the rarer medium, example we can take here the opposite of the first one, previous one, which is glass to the air. Okay, now the light ray is moving here from the glass medium, which is denser medium, to the rarer medium, which is air medium. So here speed of light will increase. Speed of light will increase and light bends away from the normal. So angle of refraction here will be the greater than angle of incidence. Again, let me just draw it simply. This is surface, this is normal, and when the light ray is moving from the let's consider it is moving from there. So it will move away from the normal. अरे ये तो पूरा पूरा सेम ही बन गया straight line. Okay, the speed of light will increase, light bends away from the normal. So here angle of refraction will be greater than the angle of incidence. Light will bend away from the normal. Okay, light will bend away from the normal. So here the angle of incidence will be the smaller and the angle of refraction will be the greater. Okay, angle of refraction will be the greater than angle of incidence. Okay, moving on to the next part. Now, twinkling of stars. How does the stars twinkle? Twinkle, twinkle, little star. So twinkling of stars is the apparent rapid change in the brightness and the position. Keep in the mind, it is talking about both of the terms, which is brightness and position. This is important, okay? So we have to remember both of these terms. So when the twinkling of stars it is the phenomenon when there is rapid change in the brightness and position of the stars when we see them from the earth. When seen from the earth, so it will change when the stars are changing their brightness as well as the position. This is nothing but the twinkling of stars. The phenomenon is scientifically explained by the atmospheric refraction. What is it? Atmospheric refraction? When there is refraction done because of the atmosphere, it is the atmospheric refraction. So stars twinkle because their light passes through the Earth's atmosphere. And now we know that it is not at all uniform. Earth's atmosphere is made up of many layers, which is continuously changing in temperature and its density. That's why whenever some kind of light ray is passing through this atmospheric layer, it does not have to pass through only one layer, but many layers. Okay, and each atmospheric layer has different refractive index. As different refractive index, it means there will be the different deviation. Okay, that's why we see the stars twinkling. Okay, so whenever we see that stars are changing their brightness and the positions when we see them from the when we see them from the earth, so it is only called as the twinkling of the stars. I hope you guys can see it. If you couldn't, I'll just read it out for you. Role of the atmospheric refraction. Refraction occurs because of the light travels at a different speed in the different layers of the air. As I have told you that Earth's atmosphere is made up of the different layers Okay, so the speed changes in every layer, and lower layers of the air are denser. Okay, lower layer are denser, and the higher layer, upper layers, okay, upper layer, these are the much lighter than the lower layers. Okay, so light rays, the refraction happens differently in this different layer. So as light moves through this layer, it bends multiple times. Okay, not only for the one time, but it changes its direction many times, multiple times. Since the atmosphere is unstable, the bending is irregular. Okay, the bending is irregular, so that's the reason sometimes we see the stars very much brighten, or sometimes we see only the faint shining of them. So that's the reason the we see the twinkling effect between the stars, because refraction occurs because of the light travels at a different speed. Every the wavelength changes whenever it is traveling through the different layers of the atmosphere, which have the different wavelength. So that's why we see the different position and the different various variation in their brightness. Okay, different variations. I hope this terms is clear. Now the very easy concept and very known, very popular concept, which is mirage. Okay, moving on to the next concept, which is mirage. So mirage is an optical illusion. Okay, it is not the real life phenomena, but it is the optical illusion. Of course, we can see it in a real life, but this is the optical illusion and not something which is in the reality. Okay, in which water like images appear on the hot roads or deserts even though no water is actually present. Whenever we see something like this, we will see the optical illusion of water in the desert, but there won't be any uh, there won't be any water in the reality. So this is nothing but a mirage. This phenomenon occurs due to the atmospheric refraction and total internal reflection of light. I hope you guys have heard about this. If not, we'll revise it quickly in the upcoming slides. Okay. So this phenomenon occurs due to the atmospheric refraction and total internal reflection of light. So conditions required for the mirage. So just keep in mind that there isn't something like water in the desert, but due to the mirage, due to the optical illusion which is created by the mirage, we see something like water in the hot desert. Okay. Now, very hot. What are the conditions required for the mirage? We will need the very hot ground, something like desert or tar road in the summer, or air near the ground, which is much hotter than the air above. Okay. So now, between the hot desert, the air which is there which is near the surface, which will be much heated or much hotter than the air above. Okay. So this create the layer of the air with a different refractive index. Similarly, in the case which when we have seen it in the different atmospheric layers, different atmospheric layers has different wavelength and different refractive index. Similarly, here when there is the hotter air near the surface of the earth, so it was the much hotter than the air which is present above the surface. Okay, so this creates a different refractive index. And now what is the role of this atmospheric refraction? Continuous refractions occurs due to the gradual change in the air density, and lower layer have the lower refractive index, which means light bends smoothly instead of sharply. Okay, so because of the lower refractive index, wait a minute, guys. Okay, guys. So moving on to the next concept, dispersion of light. Okay. Now, what does this concept means? Dispersion of light is the phenomenon in which light splits into its constituent colors when it passes through the prism. When it is passes through the prism. So, dispersion of light. When we see the light ray, a single light ray which is passing through this prism, it will get inside it. It will get refracted in this, and when it coming from the other side of the prism, we will see the constituent. constituent colors. Okay, this constituent colors of one single light. Okay, so this is nothing but a dispersion of light. The band of colors obtained through it is called as the spectrum. The band of color which we can see here, this is nothing but the spectrum. Okay, so this phenomenon is dispersion. Okay, what is dispersion? When the light in which light splits into the constituent colors, when it passes through a prism, this phenomenon or the bands which obtain through it is called as the dispersed light or the spectrum. Now, why does this occurs? Different colors of the light have different wavelength. Different color of the light have different wavelength, and the refractive index of the glass is different for different colors. Matlab, guys. So why does this happen? Because we have to keep in mind that light changes its direction when it is traveling into the different medium, and every color has its own wavelength, plus it has its own refractive index. So each color travels at a different speed inside the prism, hence each color bends by the different amount. Okay, and the color which will be seen in the spectrum will are violet, indigo, blue, green, yellow, orange, red. Okay, Vibgyor, which will be seeing in the proper following order, which is Vibgyor, the same color which we see in the rainbow. So dispersion is nothing when the light ray, a single light ray, when it is passing to the prism, it get dispersed or scattered or refracted into its constituent colors. These constituent colors are nothing but the dispersed light rays, or we can call it at the spectrum. Why does it happen? Because light, each color has its own wavelength and different refractive index. Okay, so that's why. Now, role of prism in dispersion. What does the role of prism? What role does a prism play in the dispersion? Well, a prism has two non-parallel refracting surface. White light undergoes, this is step one, refraction at the first surface. The white light get refracted, and when it come out from the second surface, which is non-parallel side of the prism, what we see, because of the different refractive indices of the different color, the light splits into the spectrum. Because each light rays had different refractive indexes, refractive index, we see the different colors when light come out of that prism. Okay, now bending of the different colors. Violet light has the shortest wavelength. If some light will have the shortest wavelength, what impact does it make? It will have the highest refractive index, because there will be the maximum deviation. The larger it will deviate, the higher refractive index will it have. Similarly, for the red light, the longest wavelength, it will have the longest wavelength. It will have the lowest refractive index because it has the minimum deviation. The shorter deviation, the shorter the lowest refractive index will it have. Similarly, here we can see that violet has the shortest wavelength, and red light has the longest wavelength in the following order, which we see in the Vibgyor. Okay, now moving on to the next concept, which is partial reflection. Partial reflections occur when the light rays travel from the denser medium to the rarer medium. Again, the denser medium and rarer medium, which we have seen. What was the example for the denser medium? When the light ray, it is traveling from the glass medium. When the light ray, it is traveling from the glass medium to the, from the denser to the rarer. So from the denser to the rarer means from glass to the air medium. The angle of incidence is less than the critical angle. Okay, now again the new term, what does it mean? The critical angle. Okay, in this case, the part of light is reflected back into the denser medium, and the part is refracted into the rarer medium. Okay, so when some light ray, it will travel into this. So some of the light rays will get refracted into the air medium, but some of this part will get reflected. Okay, it will get reflected into the same medium. So this is partial reflection, because the both of the both of the concepts are happening at the simultaneously at the same time. Okay, there is also the reflection, but some part of it also getting refracted, so that's why it is called as partial reflection. Partial reflection. Okay, the angle of incidence here will be the less than critical angle. We'll just move on in the second. What does it mean? That what is it? Critical angle. The conditions required for the partial reflection: light must travel from denser medium to the rarer medium. Okay, from the denser medium, which is glass, and to the rarer medium, which is air. And angle of incidence here will be greater than the critical angle. It will be greater than the critical angle. The angle of incidence, it should be greater than 90. Now, critical angle. The critical angle is the angle of incidence in the denser medium, for which the angle of refraction in the rarer medium becomes the 90-degree. As the critical angle reflected ray grazes along the surface, partial reflection still occur. What does it mean? When the incident ray, it doesn't get, it will, wait a minute, let me draw it again. This is the surface, and the light rays are getting refracted here, and some of it parts are getting reflected. Again, this part was the angle of incidence. It was greater from the 90-degree. It was greater from the 90-degree. When I'll keep moving it, okay, now some of the light rays which is coming from here, the light rays will keep increasing it value, and at some point that value will be equals to the 90-degree. How does it will happen? Because when the light rays keep moving along this surface, so at the point of normal, this light ray hasn't gone inside of the other medium, but it is traveling along the same line, same surface, which is there between the medium 1 and medium 2. So this angle which is created here, this 90-degree angle, this is nothing but the critical angle. Okay, which has the value of 90-degree, because here the light rays isn't moving completely inside into the second medium, but it is traveling along the path of the surface. So this angle which is created here, it is the 90-degree angle, and that angle is called as critical angle. Okay, this angle is critical angle. So as the critical angle, refracted ray grazes along the surface, partial reflection still occurs. Okay, partial reflection still occurs. Now, total internal reflection. Total internal reflection. The total internal reflection is a phenomenon in which light is reflected back into the denser medium and no refraction occurs. So we were seeing these the diagram again, which we were seeing on the last slide, that the some light rays were getting refracted and some portion of getting was reflected, till the point when the light rays were moving along the same path. So some of it path was getting reflected and refracted at the same point. Okay, again we can see that some part of it was getting reflected until it created the critical angle. And apart from that critical angle which was being made here, now what will happen, that light rays won't get into the rarer medium. It will just touch the surface and reflect from there. Okay, so this part where the light rays hasn't moved into the second medium, but it just touched the surface and got reflected back into the denser medium. So this is called as total internal reflection, where there won't be any reflection, but it will refraction, but it will be the complete reflection. So this is called as total internal reflection, in which all the light reflected back into the denser medium and no refraction occurs. Okay, now what are the conditions required for the total internal reflection? Total internal reflections occur only when both of the conditions are satisfied. Light must travel from the denser medium to the rarer medium. Again, we have the example here where the light rays was traveling from the glass medium to the air medium. Glass medium to the air medium. But the angle of incidence here, it is greater than the critical angle. Now we can see that it is greater than the critical angle. So even if one condition is not satisfied, that condition, this should be greater than 90-degree angle. Then only the total internal reflection will happen. Okay, now what happens during the total internal reflection? Entire light ray is reflected back, no refraction is formed, laws of reflection are followed, light behaves like light is reflected from the mirror. So this surface here by which the light is getting reflected, the surface act like as it is the mirror. So light rays here, which is greater than the critical angle, it comes here and get reflected into the denser medium again. So none of the refraction part has done here. That's why it is called as total internal reflection. The formation of rainbow. A rainbow is a natural spectrum of the seven colors seen in the sky after the rain. You all have seen rainbow. I like rainbows very much. And please appreciate my beautiful presentation, okay? In the comment box. So a rainbow is a natural spectrum of seven color seen in the sky after the rain. It is formed due to the dispersion, refraction, and total internal reflection. Both of these three different concepts. Similarly, this concept are similar, but somehow they are the different from each other. So this three concepts are being done in the same phenomenon here. So that is the beautiful rainbow which we see just after the rain. So a rainbow is a natural spectrum, the spectrum which we have seen formed by the prism. So here we see the rainbow, that is a natural spectrum of the seven colors in the sky after the rain. It is formed due to dispersion, refraction, and total internal reflection. Okay, now what are the conditions that are required for the rainbow? There should be the presence of sunlight, presence of light. There should be the presence of raindrops in the atmosphere, which will be acting as a prism for this rainbow. And sun must be behind the observer. Sun must be behind the observer because we see the rainbow and the sun is behind that. Okay, consider this as sun. Okay, so sun must be behind the observer and rain droplets must be in the front of observer. These rain droplets must be in the front of observer where this rainbow will be formed. Then only we can see the rainbow. Okay, now what are the conditions and what are the steps for this rainbow? Let's just see it. The formation of rainbow. The first step which we see while the formation of rainbow is the dispersion of, refraction and the dispersion entry into the droplets. Let's just consider that this is the droplet. It is not apple, okay. This is the raindrop. Okay, so when the light ray into the enter into this droplet, what will happen? The refraction and the dispersion will happen at the same time. The sunlight enter the spherical raindrop, it undergo the refraction at the air water surface. The light ray will travel at the straight path until it touches the surface of the water droplet, and the point when it will touches this, the light ray will get refracted. Due to the different wavelength, the white light disperses into the seven color. Now this rainbow, the light ray has refracted and it will just get what will happen there, that light ray will disperse into its seven colors. Okay, now it will touch the back surface of it, the total internal reflection inside the droplet. The dispersed light touches the back and surface of the droplet. Okay, so this will touch the surface and it will get reflected here. So since it hasn't come out again and it has touched the surface and reflected from here only, that's why we have called it as the total internal reflection. Then the dispersed light touches the back of the surface. Light undergoes a total reflection here because it has touches the surface and come back again. So this was a total internal reflection. this reflection changes the direction of light. Okay, and when it does, now on the step 3, when the refraction happens again, when the light ray, this light ray is coming out from this droplet again, or when it is exiting from the raindrop, so light exits the raindrop, it undergoes the refraction at the water air boundary. This was the water, excuse me. Okay, so this was the water air boundary. It undergo the refraction at water air boundary, and what we'll see here was a different color, or the different color spectrum we'll see here, and that will be the last step, how by which the rainbow has formed. I hope the formation of rainbow is clear. So it's a wrap up. Let's just review what we have studied till now. The important concept, first of all, the refraction. So refraction was the light changes when the light changes its direction when it is traveling. Keep in mind that transparent medium is very much important when we are learning about the refraction. So when light changes its direction, when it is going from the one transparent medium into the another, it changes its direction, and this phenomenon is called as refraction of light. Okay, and then dispersion, what does it mean? Dispersion of the phenomenon, when a single light ray splits into its constituent colors, so when it passes through the prism, so then the dispersion occurs. Okay, when the single light ray, it passes through the prism, and it changes into what? 7 colors, Vibgyor. So that phenomenon is called as what? Dispersion of light. And total internal reflection, when the light rays doesn't come out of the medium, doesn't get refracted, and light is reflected into the denser medium again. Okay, so light doesn't get refracted anymore, but it comes. So light rays doesn't refracted anymore, but it comes again, and it get reflected back. So this phenomenon is called as what? Total internal reflection. So I hope all the concepts that we have studied today are clear for you now. So I'll meet you guys in the next video. Till then, continue your studies and all the best. Bye bye.